Hello everyone, my name is Prashant Mohan Thakur and I welcome you all on this topic HCM&LCM brought to you by Competition Valley. This is our one-stop YouTube channel wherein you can get every study material related to CAT 23 as of now. In later stages in future we will also cover engineering and all of the examination, but for the time being we are covering CAT maybe next year. So we are doing some questions. We'll be doing some questions in this video. We have already studied various concepts about HCF and LCM. We'll be doing some questions so that we can understand those concepts very clearly. Okay, so let's start. Okay, so we'll read the question. It says find the smallest number that leaves a remainder 4 on division by 5, leaves remainder 5 on division by 6, leaves remainder as 7 on division by 8, and leaves remainder 8 on division by 9, and finally leaves remainder 9 on division by 10. You can take as forward as you want, or you can stop anywhere. We just have to understand the concept. As we can read, the question looks very tough, but again, in examinations like CAT, what appears tough isn't actually tough. It's very easy provided you understand. The first thing it says find the smallest number. Smallest number means HCF. Okay. Now, second thing it says is, we have a pattern over here. It says leaves a remainder of 4 on division by 5. When we are dividing something by 5, let's say, it leaves a remainder 4. We are dividing it by 6. Okay, we have to find one number, so the number does not change, therefore it will be still n. Now, this is remainder, okay? Now, we can consider quotient as A over here, B, and similarly we can keep going. We can take C, we can take D over here, so it's 8 7, then we can 5 6 7 8 9, and E 8 10 F9. Okay, this is what we have. Okay, so there's a concept. I hope you have written down the question over here, so we'll just try to do the concept. I'll erase it. Okay, I'll erase it because it's a longer thing, or I'll try to fit somewhere else. See, the concept over here is, see very clearly that the remainder is -1 the divisor. Okay, in all this is what we have as a common pattern. So it's a very, in one line we can solve this. So the answer would be LCM of 5 6 7 8 9 and 10 -1 flat. Okay, that's what would be the answer. If we can calculate the LCM now, it's 5 6 7 8 9. So again we do it, it should be 20. I can write it answer over here. It should be 2520. That's the LCM, -1, it's 2519. That's the answer. See, you can do it in just seconds if you can understand the question. Okay, just have to understand the question and how it has happened. We can prove this as well. It's not that you cannot prove it, simply you can prove it as well. Okay, so let me just now prove this. Okay, I'll erase this question and I'll simply prove it now. Now, as provided in the question that it leaves a remainder of 4 when divided by 5. So let's say we are dividing 5n and let's say A is the quotient. So we have 4 as the remainder. Okay, so can we write over here, now just look over here, can we write over here n? So it will be, we can write over here 5 into A -1. Now you will say, where did this -1 come from? Okay, now we are dividing something. We are dividing something by 5 wherein we are getting remainder as 4. So what it is 5 minus 1. Okay, it's very simple. Let's say we are dividing 5 by, we are dividing 4. Okay, let's say, so it cannot be, we cannot do 5 into 1, we cannot do this. Okay, so what would be our remainder? We are getting remainder as 4, or we can write remainder as -1. It's one and the same thing. So let's say when we are dividing 7 by 6, so our remainder can be 6, or remainder can be -1. This we have studied in division and remainder as well. Okay, so you can refer there as well. It can be either 7, I'm sorry, the remainder can either be 6 or -1. Okay, so that's what we have done over here. Okay, I'm just erasing this. So can we write n is like this? Now similarly for all other numbers as well, we can write n. So simply, or we can write from here, we can write 5a equal to n plus 1. Similarly, question was, okay, now we have to do with 6. So let's say b, we have to do the same thing with 6, and let's say b, and again r is 5 over here. So what would be n? N equal to 6b minus 1, or n plus 1 is equal to, I should write like this, n plus 1 equal to, doesn't matter, n plus 1 equal to 6p. Similarly 7c we can take n plus 1, n plus 1 equal to 8d we can take, n plus 1 is equal to 9e, and n plus 1 equal to 10f. Now see what has happened. Okay, so this is where we started, and this far we have reached. We have converted each one of them into value of n. So if I have to write what is n plus 1, so what it would be, 5a into 6p into 7c into 8d into 9e into 10f. Okay, so basically this is what we have to do. So we have to take, either we can take for the smallest value, or we can write n equal to, let me write this way, 6p into 7d into 8d into 9e into 10f minus 1. Okay, now for smallest value, we have to calculate what? So we have to take LCM of each one of these as we did before, and then we have to subtract 1 out of it as we did before. So even if we do the same way again, it's going to be LCM of 5, 6, 7, 8, 9, 10, 30, 210, 40, the 5, 0, 0, 2, 5, 2, 0, minus 1, 2, 5, 4, 9 would be the answer. So we have proven. Okay, but you need not to do this long. If you do this long, you will be wasting your time. Okay, so it's a very simple method, because see, the concept here is that you can write, the concept here is that if we that we can write remainders, or you can write dividend equal to divisor into quotient plus remainder. This is what we have studied, like we are, let's say we are doing 29, let's say, so we are getting 14, 28, 1. So can we say 29 would be what? Divisor into 14 plus 1. So that's why it says 29 equal to 29. That's how we used to check as a child. So can we write the same thing? We are writing over here again, divisor equal to, I'm sorry, dividend equal to divisor into quotient plus remainder. Now how are we writing remainder? That's a different thing. So if we are dividing 8 by 7, what we are getting? We are getting remainder equal to 7, or we can write remainder is equal to minus 1. You can do the other way as well by taking this number as well, but then it would be very, very lengthy again. So that's why we're trying to minimize our methods. So can we write 7 is equal to 8 into, let's say, 8 into 1 minus 1, because plus 1 would plus 1, and you can say minus 1. So what are we getting? 8 minus 1 into 7. Okay, so that's how you can do as well. So that's what we have used. Okay, that's how we have written in the form of n equal to 5a plus 1, or we can say 5a minus 1, I'm sorry. So n plus 1 equal to 5a, 6p, 7c, 8d, 9e, and 10f. And then you take LCM, because we need the lowest value of n, and you minus it by 1. That's how you get it. Okay, so let's do another question now. So again, it's a similar question. Find the smallest number that leaves a remainder of 2 on division by 3, 3 on division by 4, 4 on division 5. So similarly, we know what we have to do. 3, 4, 5, 6. Simply take the LCM. So 3 and 4 will be 12, and 12 into 5 would be 60. 62 into 3 is already there, so it should be 60 minus 1 is equal to 59. Okay, you can check it. So if you want to check, you can check this as well. Okay, yeah, it looks correct. Okay, so that's the answer. Okay, you can check this as well. Okay, if you want, you can check this. Like if you divide it by 3, so 3 into 19 plus 2, 4 into 14 plus 3, then what next is 5 into 11 plus 4, and 6 into 9 plus 5. So proof that this is true. Okay, so this is a very, very beautiful method. You can save a lot of time when you get these questions. Okay, let's do a couple of more questions.